This was a static electric uh, meter that kind of a fail attempt. I tried it though. I gave it a good try, but it didn't quite work out. And, I did show it measured 25,000 volts, but it arced across inside of it from the ground plate to the pad that the center axle was being charged from. Anyway, that's that. Huh? This is just going to be a miscellaneous movie about some experiments and my 4-foot long high voltage probe here that I made. I don't have very good lighting anywhere. I was trying to take a picture of it in the sunlight. You can see though it's pretty long, and has a meter at this end and polarity switch, and the other end has the diode is 80 kilovolt and 200 milliamp, which in all the other stuff I keep calling it 2 milliamp. It's supposed to be 200 milliamp, so I have to add that here. Anyway, that's it. This is going to be the AC measurement I'm going to take from an AC flyback. That was about 9,500 votes on that AC test. It's on this long meter probe I made, and out here at the end it has a 80 kilovolt 2 milliamp long diode going to the end. That was on this great big flyback. It's about a 3-inch diameter flyback on this circuit here that I was powering it with. This is going to be that same circuit I did when I measured the 9,500 volts AC. If I can get that on there right. It's coming from this great big, it's a 3-inch diameter flyback, antique one, I think from the 40s or something. And I have to use a flashlight trying to get this picture, so it ain't very good. But I'm gonna get the light on it right somehow. Hard to see it. Anyway, with this giant AC flyback's 3 inches in diameter. Got it on the double 2N 3055s type driver. They're on that heat sink there. We got all these resistors here on it. And anyway, this time I added the 536A to it, and going to my big diode, and all the way back down to the meter. And it's gonna be, I'm gonna start at 9 volts and see what the output ends up being. Alright. That last test showed 30,000 volts DC that was measured by the meter. I don't know how much voltage that input, to the 536A that it can take for sure. So I'm not sure how much to risk this, but I'm gonna try just for a second 10 volts in to my flyback and see what the meter says out of curiosity. Hopefully I don't screw it up. Okay, that last test there was probably about 32,000 volts DC. I'm going to risk 11 volts right quick, see what that shows. Okay, that last deal at 11 volts showed about 37,500 out. I'm gonna risk one more deal. I hope I don't blow this thing up, because I don't think it can go any higher for sure. Because but the calculations, I probably already had 10,000 going in at the 11 volts from the power supply. But I'm gonna try 12 volts, and I'm not gonna go any higher. I hope it don't blow up. We'll see what that does real quick. Okay, well, I think that looked like it was about 39,000 volts. I didn't zoom this up again. I'm going to try it one more time, because I might not have held it long enough to measure all the way. Let's see if it hits 40,000. Let me try one more time. Well, that shows around, I'd say, 39,000 volts. So that shows it was just about maybe like 10,400 going in from the flyback. That's odd though, because before I was only getting 9,500 from the flyback in AC. So yeah, there's some discrepancy in that, but it's not too bad though. Anyway, that's it, I guess. I don't want to risk it any higher. I could have barely turned it up to probably get. I'm pretty sure this meter can measure the 40,000 volts, but I don't want to mess up my 536A, so I guess I'm going to stop while I'm ahead. That's it for that test. This is my, I'm going to have to do this with a flashlight. Probably can't see it right. This is my other flyback. It's in a black box, a black wooden box. This flyback here is the modern type coil down in it. That's down here, mounted to the top of that plexiglass on top. That's out of a 32-inch TV, and it'll be running on its own internal coils on, if I get that light right, on this low resistance circuit here, with also a TV type flyback transistor on a heatsink right there, and it's all built in there with got its own transformer down in there, and bridge rectifier, which I can't get the lighting right, and two capacitors. There's a bridge rectifier, but you probably can't see it. It's underneath of those wire connectors. Anyway, so that is that one. Unfortunately, this is a narrow flashlight. Anyway, I'm going to measure that one with the meter now. Well, okay, we'll see what it says when I turn it on here. Well, I'm going to find my stick because I don't want to touch it. Oh, God. Well, that one apparently showed 40,000 volts DC positive. that one is I can only run it like 15 seconds on and then like a minute off at a time, because it's put the resistances where it was like hot as possible. So the transistor, I forget, it's the transistor or the low resistance resistor. One of them though gets real hot after about 15 seconds, but I may modify that later so it don't get hot. But that was just to get the most out of it. So there it goes to show. Anyway, I've measured 40,000 volts on this meter. Anyway, this is that flyback box. Get the right lighting. I was better off with this lighting. I could get it where, yeah, there's my electrodes on top. There's a little wire sticking out of this one. Now I've just put on there so just to demonstrate the arc that it does. Anyway, so that just to show what that is, it's like when it's on. If I don't mess up this camera, I'm going to try to turn it on right here. Now you can see, I have to zoom it in from here. It's pretty hot. That's about as long as I can run it though, because the transistor gets pretty hot in there. Anyway, that's that one. This is what I use to check the accuracy of my meter. This is a 7,000 volt flyback out of an old Xerox machine. You can see right under the HVM 2058-1N, and then the two lines under it, under the 0 of the 20, you see minus 7 kV. I have to hold this magnifying glass there. It's the only way this camera can see it. Anyway, that's what I used. I just wanted you to be able to see that. Anyway, that's what it looks like. It's out of an old Xerox machine. And anyway, so that's what I'm going to test now on the meter. Okay, I'm going to try that Xerox flyback, and it's supposed to show 7,000 volts on here, which would be like on the bottom line on this gauge on the meter, the one with the 0, the 30, and the 60, 90, 120, so forth. That first mark after the 0, it should point just inside the left side of that first little black mark that's drawn there, because that mark is the 7,500 volt mark, so it should be just touching it. We're going to see if it is. originally, that little resistor I had on the outside of it was had it calibrated to where it was showing 7,000, but I'll see now it's showing like 8,000 or so volts on that 7,000 volts. So the polarity switch was kind of old that I used on the meter, which is right down there, here on the right side. And that switch had there's a dang fly on it, had a little bit of a connection problem. There was a little bit of resistance in it on one side. I had to set that to a negative input for that deal. I tried it a while ago and it wasn't measuring nothing. I had to switch the diode around and put it on negative. Anyway, I'm guessing that resistance in that switch got lower than what it was when I started out. So anyway, yeah, you have to subtract a little bit from what I was measuring on all those measurements. But that was pretty close though. That's it, I guess. Anyway, this is the plan of the meter. How I made it is just a face off an old digital multimeter analog type that was 20,000 volt, 20,000 ohms to the volt movement. And then I put the polarity switch in there, and then one side is of the meter, the negative side is going to earth ground. Between earth ground there's 11 kilo ohm quarter watt resistor, and then coming up and then going back across to the positive side of the meter is 16.7 kilo ohms. Originally it was 12 kilo ohms, but I added a 4.7 kilo ohm to calibrate it closer. And then above all those is 10 200 meg ohm 8 watt 20 kilovolt resistors, 10 of them in a row all the way up to the end. And then at the end there was a 80 kilovolt 2 milliamp diode screwed on to the end of it so I can measure AC and DC somewhat. Anyway, so yeah, that's some paper I had on it. Anyway, I wanted to put that in there. And that's it, I guess. Also, I forgot to say that a couple of other points about it was that I never could get it to like the meter when it goes to full swing. It's actually at full swing it would be pulling twice the current. I could never get it to pull the exact current the meter would pull at full swing. It actually pulls this total current at half swing, but half swing is the 90 kV mark, which I ain't never really going to measure nothing that high because that'd be crazy probably anyways. And the other thing was that whenever I was making it where I had in the plan all them 200 meg ohm resistors, at first there was just a 200 kilo ohm resistor in place of where all that was. And so I had it on my my bench power supply so that I was marking on it. That's how I marked it off. It went from 0 to 20 volts. But then I switched from the 200 kilo ohm on that end to 200 gig ohm, and then so instead of 0 to 20 volts is 0 to 200,000 volts. And that's it anyways. It's pretty long. It's the other thing is it's about 4 foot long with the diode and It's a big PVC pipe, and coming all the way down to that end, and down here's where the earth ground comes out. And then you got your polarity switch over here. I can switch positive and negative. And I just have to go down there. That diode down yonder unscrews. I unscrew it and flip it around backwards and screw it back on if I go the opposite polarity. And okay, that's it now, I guess.